Alright, so in this video I'm going to talk a little bit about what characteristics we know about a polynomial and how we can use that to sketch a graph of the polynomial. So I'm going to do one that is given to you in factored form, and I'm going to give you one that's written in this form where we have our three separate terms and we're going to need to factor. Okay, so for this first one, I'm going to think about a couple things when I'm graphing. I want to think about what the end of my graph is doing, the end behavior, and then I also want to think about what's happening in the middle. And so I'm going to think about my roots or my zeros. Where is my graph going to be touching the x-axis? And if I find those things, I'm in pretty good shape to get a basic sketch of my graph. So let's focus first on our end behavior. In order to figure out the end behavior of our polynomial here, I need to do the leading term test, because I know that if it's even and positive or negative, it's going to do different things. If it's odd and positive or negative, it's going to do different things at the end of the graph. So let's take a look. Now, I can multiply this whole polynomial out, but since I only really need that leading term, I can also just think about if I were to multiply all of these terms together, what would that leading term be if I had it in expanded form? So I have x squared times x times a negative 2x, and if I multiply all of those together, I would end up with a negative 2x to the fourth, and then the rest of the polynomial. But this would be my leading term with my highest degree. So if I think about the end behavior of a function that has this as its leading term, this is an even exponent and a negative leading coefficient. So this is going to have the same pattern that all even negative polynomials have. And I'm thinking in my head, I can picture that even negatives in general are going to be headed to negative infinity on both sides, on the left and the right. In limit notation, we would write that like this: the limit as x goes to negative infinity of x, that's the left, is headed to negative infinity, and the limit as x goes to infinity on the right side, it's also headed to negative infinity. Okay, so I'm going to keep that in mind. That's what the end of my graph should look like. For the roots or the zeros, let's think about that now. I already have it in factored form, which is helpful. So I want to think about which x values would make this equal to 0. So the one in the middle, if I had x equal to negative 4, that would cancel that out. If I think of this one over here, I might need to off to the side actually set that equal to 0 if I can't tell what would make it 0, and subtract 1 and divide by negative 2, and x would be 1/2. 1/2 is going to make this factor 0, so x equals positive 1/2. And then lastly, this factor out front, x squared, what would make that 0 is just 0. If I have 0 squared, that would be 0, and the whole polynomial would be equal to 0. Okay, so I've got 3 roots or 3 zeros on my graph. Let's think about the multiplicity of those so that I can figure out whether it's going to be crossing through that point or whether it's just going to be tangent and bouncing again against these points. So let's take a look. Negative 4 comes from this factor, and I notice that it has an exponent of 1, which is odd, so this is going to have odd multiplicity because it has a multiplicity of 1. 1/2 is the same. It also has an exponent of 1, so it's also going to have odd multiplicity, so I'll go ahead and put those both in that category. And 0, if I look at 0, that factor is squared, and so that is an even number, so this one is going to have even multiplicity because it has a multiplicity of 2. So odd multiplicity, I know in my head, means that it's going to cross the x-axis at those points. Even multiplicity means at that point at 0, it's not going to cross, it's just going to be tangent, or it's going to kind of bounce against that point. So let's go ahead and draw a sketch of what we got so far. If I draw my axis here, and I know that it's crossing, let's go ahead and 1, 2, 3, 4, 1, 2, 3, 4. It's crossing at negative 4, it's going to be tangent or bouncing against 0, and then it's going to be crossing right here at 1/2 between 0 and 1, nice and tight. Okay, so remember my end behavior is going to be from negative infinity from both sides, so I'm going to start from down here. I'm going to go through -4. I'm going to go and just touch or bounce against 0. And then I'm going to go through my 1/2 and head down to negative infinity again on the other side. So I know that's a little bit messy there because they're right next to each other, but I touched 0 and then I went up and through 1/2. All right, so that's a pretty good idea of what my picture might look like. Let's take a look at this next one and see what's the same and what's different. Let's start again with my end behavior. That could be one thing that we think about as we start to try to graph this. This one's already to where I can see my leading term. So I'm already checking this out and I'm looking at the exponent. The exponent is odd. And in front I don't have anything, so that's a positive 1. So this is what I would call an odd positive. So thinking in my head, that would look like this. It would be down to negative infinity on the left and up to positive infinity on the right. So my limits would be limit as x approaches negative infinity of f of x is headed to negative infinity, and the limit as x approaches positive infinity of f of x is headed to positive infinity. Okay, I know what the end looks like. Now let's talk about my roots or my zeros of the function. And for this one, I'm going to need to do the factoring because it's not already factored. Now this is a cubic, so for a quadratic I could jump straight to factoring with box method or whatever you use for that. For a cubic, I need to take a look at my function, and what I notice is that there's an x term in all 3 terms. So that's a common factor that I can factor out front and say x times x squared minus 5x plus 6, and I can check by distributing x back in there. X cubed minus 5x squared plus 6x. This is the same as what I started with, just factoring an x term out there. Now I have a quadratic that I can factor, so I'm going to say x squared 6 minus 5x. If I say -2 times -3,